And there we go. The recording has started. So yeah, first question for today. Given the number pattern 0, 3, 6, 9, so on, determine a formula for Tn. So what is the formula that would describe this number pattern? Now, what we're going to look at is the first difference between these terms seems to be 3. So that 3 is probably going to be involved in the formula somewhere. And for a lot of us last time, we just basically said, well, look, we'll start by writing 3n. But the problem is that doesn't fit the number pattern that is there. So you're going to have to help me figure out what else needs to go into this number pattern. You can pop it in the chat when you feel confident. What do you think is going to go after that? Ooh, Akwande, can I suggest that you leave and come back? It might be an audio thing on your side. Okay. Pabilelo, you're quite right. This should be -3. All right. So the general term formula or the nth term, these are two different ways of describing it. The general term. So some teachers will say the general term is this, or the nth term is this. Or some teachers will even say the general term formula for this number pattern is that this is called a linear or a arithmetic number pattern. And basically, it's just going up in 3s. All right. Now, a harder question is this. Is 118 a term in the sequence? So is there a point at which somewhere down the line, this number pattern gets to 118? And how would we check that? I would love a student to tell me with their voice what technique they would use to check. We've never done a question like this. So we've got our general term formula. Is 118 in this number sequence? Who can give me a tip to help me try and figure out, is 118 in this number pattern? Okay, so Bukle says no, and Bukle might be right, and Bukle might be wrong. I need a process. I need a way of actually showing with evidence whether 118 is in this number pattern. Can someone give me a first step? In the last lesson, we did something with this 118. Where did we sub it? If we thought it was, now we don't know for sure, but if we thought it would be a number pattern, where did we sub it in? Okay, Atlechang, I agree. We are going to make Tn 118, and we are going to try and solve for n. And what this is going to try and tell us is if n is a whole number, that's the number of the term in this pattern. If n is fractions or negative, then we know 118 cannot be. So help me solve for n, everyone. What do you get for n? Use your knowledge of algebra. So we add 3, and then I think we divide both sides by 3. And what do we get for n then? Okay, the problem is we get 40,333 or 40 and a third, and therefore, so we can say 118 is not in the sequence, as n is not a whole number. And it has to be a whole number. Like if you think about term number 1, term number 1, term number 2, term number 3, the positions in a number pattern can only be whole numbers. You can't have position 1.5. It just doesn't work. Okay, now, so we've done these first two. Now we're going to move on to question C. Which term is the first term to be bigger than 217? Ish, things are getting tricky here. I don't even know exactly what the answer is to this, but I know a process that I'm going to use. What do you think I should do with this 217? So they're kind of saying, look, if I imagine this list keep on going, at some point there's a term that's bigger than 217 in the list. But at the moment, I don't really know what that is. Can anybody tell me where they would start? Where would you start with this, finding which term? I mean, if you're stuck, what's the, who has an idea? I want you to, sharing is caring. Let us share our knowledge with our classmates. Give me a thumbs up if some of you were thinking, I can just go 217 equals 3n minus 3. Give me a thumbs up if that was like, you thought, well, I mean, that's what I think. Because if I know what n I get that's close to 217, I can probably work out the term that's after that. So help me solve for n. What do you get for n if you go 217 equals 3n minus 3? So I add 3 to both sides, and I get 220 equals 3n. And then I divide both sides by 3, and I get 73 and a third. Okay, now, what that means is that 217 is not in this number pattern. What is going to be, now remember, I need a term which is bigger than 217. What is going to be the next term that is allowed after 73 and a third? What's going to be the next term in the list, or the next position in the list after 73 and a third? It's going to have to be 74. So it says, which term is the first term to be bigger than 217? It's the 74th term. But, okay, so it's the 74th term. Now, for bonus points, can you work out for me what is the 74th term in this number pattern? So you did the hard work. You worked out that, look, 217 is not in the pattern, but the next item that is the 74th item. And now can you work out what that 74th term's value is? What do you need to do? You need to use the original formula, and you go 3 times 74 minus 3. And what do you get? Pabilero, Buchle, Callan, you guys are on the money. It's 219. So if you imagine things going on and going on, eventually, if you keep going, there's going to be a point at which I get to 219 in this number pattern, and that is going to be T74, or the 74th term. Okay, now here's another question. What is T75 going to be without using the formula? What is T75 going to be? I'm just going to add 3 and get 222. Fantastic, everyone. That was a toughie. That was a toughie. So if you need to re-watch that on the recording, please do so, because I know that would have given some of you a bit of nightmares. All right. I just want to, before I move on to quadratic patterns, I just want you guys to look at this layout. Sometimes they lay it out like this. So can you please work out for me the values A, B, and C? Can you work out for me the values of A, B, and C for this number pattern? Now, again, if I look at this, I'll do it below. The first differences seem to be 3, which could be helpful. What is the value of A going to be? What is the value of B going to be? What is the value of C going to be? Okay, A is 19. B is 22. Let me write these in. And then this one is going to be 25. All right, now what is going to go here? This is another way of writing, asking what is the general term formula. So what they want in that bracket there is they just want whatever would have gone here. So imagine Tn equals something. What do you think is going to go in this last bit here? So if you imagine my formula, because I'm going up in threes, it would be 3n something. But now 3n doesn't give me the value of my first term. My first term was 7, if I look at it there or there. So I need to go plus 4. So then this is going to be 3n plus 4. Okay, so that's not so bad. Let's just do one more of these before I move on. Give me a thumbs up if that made sense to you. Okay, fantastic. Okay, here is another one. I want you to fill out, I'll say A, B, C, D, E, F, G. Can you figure out what all those values are? Oh, Pila, let me go back to the last one while other students do this one. Where did the plus 4 come from? Okay, so are you happy that it's, if you look at the very first term, you will notice that we're going up in threes here. All right, so we're going up 7. Wait, let me just draw it like this. That's 3. And that's going up in threes. Now, because it's going up in threes, we write this. But if I had to put a 1 in at this stage, I would only end up with 3 as my first term. But my first term is 7. So what do I need to do to get to 7? I have to go plus 4. And then you'll notice that if I go T1, I get to 7. But not only that, I also get the second term correct. Does that help, Peter? Fantastic. Thank you for your question. Okay, let's have a look at this one. Well, A is going to have to be 5 because really the second term is 5. Then this is going to be 7. And then this is going to be 9. Then D, what is D going to be? Maybe I should just write this in as I go. 5, 7, 9, 11, 13, 15. The only one that's tricky is G. What's G going to be? So I'm going to get 2n, but then I need something to go with that. And then what goes in this block? So it has to just be plus 1. So 2n plus 1. Okay, now here's a sneaky one. What if I said to you this was 101? Could you work out what goes over here? So if this was 101, if the position of the term was 101, could you work out what goes here? So all we would have to do is we would have to go 2 times 101 plus 1 So 2 times 101 plus 1. And what would we get? We would get 203. So sometimes schools write it in this thing where they say the position of the term. So position 1, position 2, the value of the term there. Okay. We have done lots of linear and arithmetic patterns. It is time for us to go to a new type of pattern. But I think you guys are looking good in that one. Okay, now let's look at a new type of thing. This question, if I look, I'm going to ignore this completely. And I'm just going to say this is a number pattern. This number pattern is behaving very differently. I don't see a number that is straight away linking these terms together. So if I have to say what is the first difference here, how do you find the first difference? Well, I'll go minus 15 minus 7, and minus 15 minus 7 is minus 15 plus 7, which is minus 8. So the gap between here and here is minus 8. But if I go to the next one, actually, it's going down by 10. So I actually don't even need to do that fancy stuff there. And then it's going down by 12. So this is a decreasing, and the first difference is not constant. Give me a thumbs up if you followed me so far. Okay, now, if the first difference is not constant, we need to go and look at what we call the second difference. And it's where we subtract the first differences. So if I go from minus 8 to minus 10, I can see I've lost 2, or I've taken away 2. Another way of doing this is to say minus 10 minus minus 8, which is the same as that, which is the same as minus 2. But it's also easy to see that I take away 2, and then I take away 2 again. So what we say in this number pattern is we have a constant second difference. And when we have a constant second difference, we know that it is a quadratic pattern. So it's not going to be a arithmetic or a linear pattern. It's going to be a quadratic pattern. Now, I'm going to teach you how to find the equation of a quadratic pattern, but let me start by giving you the standard form of a quadratic pattern. That is the standard form of a quadratic pattern. What does it remind you of a little bit? Are you having some flashbacks from earlier in the year? Who sees some similarities? It looks like a trinomial. Yep, a trinomial. Or we could say it looks a little bit like the quadratic formula, except instead of these being x's, they're n's. Yeah, Amokalang, quadratic formula, quadratic equation, functions, exactly. So there is some relationship. Now, we're going to get to that, but for now, we're just getting comfortable with this new type of pattern. So I want you to take this number pattern and find me the constant second difference. If it is. If it's not, then maybe it's something else. But find me, hopefully, the constant second difference. You go work that out and tell me what you get. Maybe it's not a constant second difference. I'll I'll give you a hint. Start with a first difference. Look at the first differences. And if I like drawing these little smiley faces to link them, I think this has gone down by 12. How much has this next bit gone down by? What you could do is do this, which is really like saying that. I think this is minus 18. And then to go from here to here, it looks to me like it's take away 24. Now, the first difference is not constant, but I kind of expected that. So now I'm going to go to the second difference. And let's see what I get here. When I go from minus 12 to minus 18, I lose 6. When I go from minus 18 to minus 24, I lose 6. Ah, the second difference is constant. So the second difference is equal to minus 6, and it's constant, and it is a quadratic pattern. Give me a score out of 10 for how well you're understanding this first difference, second difference thing. Give me a score out of 10. 0 is no understanding. 10 is perfect. 5 is okay, but I need to improve. How are you feeling about this thing? We're going to practice it a bit more. You'll get better, so don't stress if you... I'm just getting a feel for the group. Okay, let's go to this next one. Find the constant second difference for this number pattern. What do you get for this? So let's go. It's my first difference. What are you getting for your... Are you getting a constant second difference? So what I see is that the second difference is equal to minus 4. Okay, so again, this is kind of how we can identify a quadratic pattern. If we check and the first difference is not constant, it's not a linear or arithmetic pattern, we go to the second difference. If the second difference is constant, we know, okay, now we've got a quadratic pattern. What method must we use? Okay, let's do another one. Then we're going to take a break. So first of all, I want you to check. Ooh, okay. Before we worry about what they're saying, can you find me the second difference for this number pattern? It seems to indicate it's a quadratic sequence. Can you find me the second difference for this quadratic number pattern? Let's have a look. So I'm going up by 5, up by 9, up by 13, and then I'm going up by 4, and then I'm going up by 4. So the second difference is 4. Okay, now, ladies and gentlemen, we need to figure out, even though we don't know the formula, we need to figure out what is the next number in this quadratic sequence or quadratic number pattern. Now, I know I haven't told you about the formula, but does anybody have an idea of how we can get the next number in the pattern, even though we don't know the formula? Who can share some wisdom with me? I can feel the knowledge through the internet. Somebody wants to share the knowledge. Callan and Atlechang have given me some good tips. They've said, take the 13 and add 4 to it and make another little smiley face. Okay, and then if you add what, okay, thank you, that's super helpful. So what is the next number going to be? After 36, in this quadratic number pattern, what's the next value going to be? So 23, 36, and if we add 17, we are going to get 53. That is so clever. Look at how you, even though you don't know yet what the full formula is. Just by looking at the pattern of the first differences, the first difference is forming its own linear number pattern. And in reality, I could actually just keep going. Now that I've seen this, I'm like, hold on. I could just go, what's the next one? So let's just actually get the next one before I get too excited, and then we'll take a break. So what comes after 53? What's going to be the next number that comes after 63? Sorry, 53. I think I have to add 19. So maybe I should have put plus 19. And then I go, add 19, and I get 72. Oh, I lie. It's not, is it? Wait. So I added 17 to get this. If I add 19, what do I get? Don't I get? Oh, I'm making a boo-boo. Sorry, my mistake. You're right, 74. Perfecto. All right, give me a thumbs up if you feel like you know how to extend a quadratic pattern. So step 1, check that it is a quadratic pattern because there's a constant second difference. Step 2, can I extend it by using the first difference pattern? Okay, everyone, it's time for a break. So I want you to get away from your desk, stand up with me, and let us just take a quick break. We'll take 3 deep breaths. One more. Okay, then I want you to get nice and relaxed. And I want you to just shake your arm around a little bit, nice and loose. Shake this arm, get the circulation moving. Shake your legs. Shake them. And I want you to go, just twist a little bit. And then let's roll the shoulders back a little bit. Okay, then we've done breathing, we've done some circulation. Let's do some heart rate and some blood pumping. And we're just going to do the jumping jack, and we're going to do 15 of them. So clear the space around you. Make sure you're doing this. Even if you feel silly, we can do silly if it means that our maths is going to improve, right? Like that's just part of the process. Okay, 3, 2, 1. Let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And that is all she wrote. Oh, give me an emoticon. Just tell me how you're feeling. How are you feeling after that jumping around? Is anybody getting super like good at jumping jacks? Does anybody feel like they could take me in a jump off? Okay. Maybe we should have a competition one day and see. We should totally do this. We turn on our cameras and we see who can do the most jumping jacks in a minute. Who would be up for that? I think we need to do this. We need to see who is the jumping jack champion. You've all been training for many months now. It's time to put you under pressure and see what happens. Okay. See if you can do this one. Here is a quadratic sequence, and it says it's a quadratic sequence. I want you to see, can you figure out what that missing term value is there? Now, it does say that it's a quadratic sequence, which means the second difference must be constant. But it does mean that that first bit is a little bit tricky. But I can do that one. What's that going to be? That's going to be 9. And this one is going to be 13. Okay, so that's the tip I'm going to give you. Can you work out what that missing value is going to be there? Anybody can give some tips? How do I, if I know this is it possible to work out what this is? I think this has to be 4. But then if I'm that, couldn't this be 4 as well? Yes, Pabelelo, what can I do for you? Go ahead and ask your question.
So I was saying that because you asked what should we do, I was saying we can use the second difference to find our first difference.
Very, very good. So what would you say the first difference that comes kind of before this one? So there's 9, 13. What was this first difference going to be? How would you use the 4? Do you understand what I'm asking? We might have lost Papalelo there. So I was thinking you take away the 4, so this would have to be 5. And then this one over here would have to be like 1, right? So if I'm going minus, so minus 13 to get there, minus 9 to get there, minus 5 should give me, oh wait, hold on, I'm going backwards. Hey, so I'm going minus 13, then minus 9, then minus 5. I should get minus 11. And then I should get minus 1. Yep. So I say the missing term is minus 11. Now that was tricky, but I mean, that's why we're learning some more difficult ones. Would anybody agree with me on the minus 11? Let me write it in a smaller, give me a thumbs up if you followed me with the minus 11. Give me a thumbs down if you're like, hold on, man, what game are you playing here? That was tricky. Okay, I need to give you another one. Okay, so just to explain what I did, I basically filled in the things that I could. Because it said the quadratic sequence, it was a quadratic sequence. The moment I had 1 second difference, I just used the going back and forth thing to help me. And then I just went, well, 16 minus 13 gives me 3. 3 minus 9 gives me minus 6. Minus 6 minus 5 gives me minus 11. I was just going backwards. But let's do another one like that, just to build up our confidence. So here we go. It says, this is a quadratic sequence. There's no debate. Find the value of the missing term, which is the very first term. So see if you can find that missing dot at the beginning there. I'll let you fly solo. If you need a tip, pop your hand up like Papalelo there, and we can chat, or you can put a comment in the chat. But let's see if you can figure out that missing value there. So I think that difference has to be 3. Now, what does that mean? So the second difference is 2, so that must be 3. What is this original number going to be? I think it has to be 5. Because if I take away 3 from 8, I get 5. Or if I go forward, I can see it goes up by 3, up by 5, up by 7, up by 9. And we go like that. Give me a score out of 10 for how you feel about this type of question where 0 is no understanding, right? So that's 0. Then 5 is okay, but needs to improve. 10 is like, I know all of this. Where are you on my 10-point scale? Awesome. Awesome, awesome, awesome. Okay, now for those who are feeling unsure, remember this lesson is recorded. You just re-watch this a little bit. Maybe, take your time, re-watch as you need, and we'll go from there. Let's try and do this one. One more like this, and then we'll move on to the general. I'm going to teach you the method we use to do this. Can you find me the missing term? So the missing term is T2. We've got T1, we've got T3, T4, T5. I'll give you some time to do this. So let's use our same process. And we don't know what that is. But we know it's a quadratic sequence, which means our second difference. So what's this going to be? So what's my missing number going to be? So I went backwards by 13, backwards by 9, backwards by 5. That should give me a 6. Okay, one more question like this. What is the next term going to be? So after 33, we've got a quadratic sequence or a quadratic number pattern. After 33, what is the next? Or 1, 2, 3, 4, 5. What is T6 going to be in this number pattern? What is T6 going to be? Well, this is where I think our first difference is going to be super helpful. I think that if I add 17, my T6 is going to be equal to 50. All right, everyone, just to point out, when we have a quadratic pattern, the first difference is a linear number pattern. The second difference is constant. But once we know this, we can use it to find missing terms or to extend that number pattern. Okay, so you have done super well. In fact, you've done so well that I'm going to take you on to basically explaining to you how do we find the... Now, I'm not going to go through all of this, but I'm just going to make sort of some basic acknowledgements. So if we have a quadratic number pattern, we know it's going to have that form. What we really need to do is we need to know what A is, what B is, and what C is. So if we know what those numbers are, we will then know, for example, if the number pattern is 3n squared plus, let's say, 1n minus 2, in that scenario, A is 3, B is 1, C is minus 2. But we need to find a way that we figure out those values so that it fits with our number pattern. Okay, now, there's a lot of algebra on the screen that I can talk to you about in another lesson, but the main idea that we use is that the second difference, okay, is always 2a. So one of the first things we do is we work out what the second difference is, and we make it equal to 2a. So that is going to be what I call step 1. Make the second difference equal to 2a, where the a is just the... let me write this out the whole way. Where the a is just this a here. Now the second step is to say, what is the first difference? So what is the first difference? If you look at this thing of algebra, here is the first difference. The first difference is equal to 3a plus b. Now, for the moment, you're just memorizing this. In the next lesson, I will explain it. Today is just getting used to the recipe. Okay, then the third step that we need to know about is what is the value of T1? Well, if you look at this drawing over here, T1 is just A plus B plus C. So in order to figure out the general term formula for a quadratic, you use these 3 steps. So take a moment to write down these 3 steps because I'm going to show you an example now of how this works. The fancy algebra that's here is just an explanation or a proof of why this works, essentially. But I'm not going to do that today. I will talk about that if we have time towards the end. But in reality, the method I want you to learn today, or learn a little bit of it. So second difference, which is constant. So I should actually say the constant second difference is equal to 2a. First difference is 3a plus b. The first term, T1, is a plus b plus c, where these a's, b's, and c's are part of this thing. Give me a thumbs up if you've written down my 3-step plan. Okay, ladies and gentlemen, let the magic begin. So, if we go back to this number pattern that we have just done, right? You were exploring this. Let's use the 3-step process to help us work out what the general term formula is. So the very first thing we do is we say 2a is equal to the second difference. What is the second difference for this number pattern? What is the second difference for this number pattern? Well, it's over here. Here's the second difference. It's going to be equal to 4. Okay, if 2a is equal to 4, what is a going to be equal to? If 2a equals to 4, what is a going to be equal to? A has to be equal to 2. So you've already figured out that this over here is a 2. Okay, now the next bit. We had to go 3a plus b is equal to the first difference. Now, what is the first difference here? Be careful. Be careful. What is the first difference? Helen, well done. It's 1. Yes. Because if you look at the first difference here, it's the difference between 5 and 6, which is 1. Now, that was sneaky. Okay. The first difference is 1. If you know that a is 2, can you work out what b is? So you've got 3a plus b is 1. You know a is 2. What is hang in there anyway. So I'll help you. You have a 3 and you know that a is 2. You know that this is true. If only we could move 3 times 2 to the other side. Well, what is 3 times 2? It's 6. So then b would be equal to 1 minus 6, which is minus 5. So now we know that this over here is just going to be a minus 5n. Okay, last bit. The third step is a plus b plus c is equal to. Can you remember what a plus b plus c was equal to? If we look at our checklist, what was a plus b? I remember it being equal to T1, or the first term. What is the first term in this number pattern? I think the first term is 5. So the very first term here is the value 5. But now you need to work out for me, what is the value of c? You know what a is, right? You've worked out that a is 2. You know what b is. Can you find what c is for me? So I'm going to take A, which is 2, minus 5, which is B, plus C is equal to 5. I know that C will then be equal to 5 plus 5 minus 2, which is 8. So now let's go back to the top. My quadratic number patterns formula is equal to this. Now, we need to check. So I want all of you to take out your calculators, and I want you to put a 4 where n is. So we are going to put a 4 wherever I see an n, right? So there's a 4, and I'm hoping that the number that we get is the same as T4 in my list. So T4, according to this, was 20. So what are you getting when you plug T4 or 4 in using that formula? What do you get? Tell me what you get when you use that formula. It looks like the mathemagic is happening. Let's just to be careful, let's check one more time. Find me T6. Use the formula you just got to figure out what T6 is. Okay, so the good news is we're all getting 50, which means the method works. Now, in the next lesson, what we're going to do is we're going to practice this method, but it's really going to be just the same method where we say, look, we know that the second difference is always equal to 2a. We know the first difference is equal to 3a plus b, and we know that T1 is equal to a plus b plus c. And then we will work out what a is equal to. We will work out what b is equal to, what c is equal to, and then we will have a general term formula for a quadratic number pattern. But we need a whole lesson to actually practice that. So everyone, give me a score out of 10 for how you are feeling about the content that we covered today. I know the last bit was a bit tricky, but mainly sort of how are you feeling about the content that we covered today? Give me a score out of 10. Okay, now for those of you who found it tough, remember you can watch the recording. The other thing that you can do is I've just put the link to this week's quiz in the chat stream. Now, the quiz this week is not super hard, so a lot of you can literally go and do it now and be done in 10 minutes, I promise. So I really encourage you to go and do that quiz. And then the other thing is you'll notice that I've also put a thing asking you for your term 3 marks. So there's an extra question in the Google Classroom this week which says, what did you get for term 3? Please answer that so that we can keep track of how things are going over time. All right, and then everyone, now we've got to that point of the lesson where it's bonus time. So for those of you who have had all the maths you can take for one day, that's fine. You're completely allowed to leave. Give me a wave as you leave and it's completely fine. But there has been one question that has been submitted by a student. And the question is on circle geometry. And so I'm just going to take a moment, maybe I'm probably going to take about 10 minutes to go through this question on circle geometry. So if you would like to hang around for that, then I am completely, but I'll give you a minute now just to decide, are you going to stay around? for the circle geometry. And if there are any final questions, otherwise give me a wave as you leave class now. Okay, everyone. Perfect. Let's have a look at the circle geometry question that was submitted. If you look at this situation, you'll see that I've drawn some stuff already, but I just want to highlight the major issues. It says ABC is a tangent to the circle. So let's go and find ABC. Okay, that's ABC, that's a tangent. Now, whenever we see a tangent, we know that there are going to be theorems related to that. For me, it's the tan chord. It also says that there's a straight line, and I see these parallel lines over here. These arrows are indicating that there are parallel lines. Now, those parallel lines mean fun, or the relationships that are involved are going to be like corresponding alternate and co-interior. Atlekan, yes, you can absolutely send me more questions on timelines if you'd like. In fact, I'll even do them. If you send them through now, I'll even try and do them now if you've got the time. Okay. So give me a thumbs up if you understand the yellow thing I drew, and then you also understand the parallel lines that I was showing you here. Okay, now there's some other stuff here, but we'll get to that in a moment. Okay, it says, calculate in terms of X and Y the sizes of the following angles. Give reasons for your answers. Now it says ABF, so let's just find where ABF is. Okay, so let me take this away for a second. ABF is here. It's the same angle as B1. So that's ABF. And what I said, in fact, I'll even draw it in for you here, is that ABF is equal to X. And the reason it's equal to X is the tan chord theorem. So we say tan chord theorem. So this one over here is equal to X. If we look at BCD, BCD is down here. Here is BCD. And what I'm going to say is that this is also equal to X. And what is the reason going to be for that? Who can tell me what the reason is that this one over here is going to be X? So I think this is an upside down F. And so this is going to be corresponding angles, and the parallel lines are going to be BF parallel to CD. So I've got that's an X and that's an X. Give me a thumbs up if you followed that. Oh, see, Colin got that perfectly. Okay, now moving on. I'm going to get rid of some of the stuff on the top here because I think I've already written it down there. So let me get rid of all this. Let's look at the next question. So it says, why is BEDC a cyclic quad? Okay, what does it even mean for something to be a cyclic quad, and where is this thing? So here is BC, and that's D, and there's an E involved, so there's that. Okay, so this is a quadrilateral. We need to show that it's a cyclic quad. Now, a cyclic quad means that we can fit a circle through that. But there's only 3 ways to show something's a cyclic quad. So 3 ways to prove a cyclic quad. So, and they're the converse theorem. So I can say the converse of the exterior angle of a cyclic quad, the converse of the opposite angles of a cyclic quad are supplementary, or I can say the converse of angles in the same segment. So there are only 3 ways to prove that something is a cyclic quad. Maybe should I write that down for you? You probably would appreciate me writing that down. So let me write that down. What are the 3 ways of proving something is a cyclic quad? You can say converse exterior angle cyclic quad, which I'll explain what that means. You can say converse, what did I say? Converse opposite angles in cyclic quad, or we could say converse angles in same segment. So those are the 3 reasons. What you're doing in terms of the shape is if you have a quad, so if you have a quad, so here's a quadrilateral, if you can show that the exterior angle is equal to the interior opposite, you then know that this thing is a cyclic quad. If you can show that the opposite angles are supplementary, okay, so if you can show that together they add up to 180, then it's a cyclic quad. Or if you have that sort of butterfly shape, and you can show that that angle there is equal to that angle over there, this is converse angles in the same segment, then this thing is a cyclic quad. So let's have a look at this. If I look at my pink one, which of the 3 ways am I going to use to show that the pink thing is a cyclic quad? I had a lot to say there, but I want to point out, can you see over here that this thing over here is an X? So that thing over there is an X, and earlier on we proved that that was X. So we have to use converse exterior angle cyclic quad. Because this is equal to this, we can say, let me write this down, B, oh, that's too big. B, E, DC is cyclic quad, and that is the reason. This is equal to X, and that's the reason. Give me a thumbs up if you can understand why the pink thing is a cyclic quad by using the blue angles. Okay, fantastic. Now, the last question is, which 2 other angles are equal to X? Now, the thing that you have to do here is realize you have just proved that the pink thing is a cyclic quad. So you can use your cyclic quad to help find those other angles. So what I want to point out first of all, can you see these 2 blue dots? That one is X over there, which means D2 has to be X, and that's just the butterfly shape, or what we call angles in same segment, right? So we're just saying that D2 is equal to X. In fact, let me even, instead of using that, let me just write X, and that really was an X, because of angles in the same segment. Now, what other angles equal to X could we find? So if I have F2 plus 3, I don't know about that. I would say, is there anything else that we could? Ooh, I wonder if. Oh, Peter. Okay. So, Peter, what I was saying was that this pink thing over here is a cyclic quad. There is already an x over here. And it has to be equal to this angle over here because these are angles in the same segment. Or angles on the same arc is another way of saying it. These two angles must be equal to each other. Does that help you? All right, now we need to find which two other angles equal to x. Okay, so is there another thing that we can use here? Exterior angle, that's equal to x. I suppose, we've used that one. I think we've got all of them. So can we just use, is there anything that I'm missing? Find two other angles equal to x. We've got that's x, that's x, that's x. I think that's it. I might be missing something. Exterior angle. I'm not sure if we're allowed to use those ones. We got that. We got that. We got D2. Is there anything else that I'm missing? 2 plus 3 plus 4. B 2 plus 3 plus 4. So if we take that one, that would be 180 minus x. So that would be 180 minus x because it's on the same straight line. So we wouldn't get that one. Okay, I will have a look at this. I'll let you know. At the moment, for whatever reason, I can't. Oh, wait, hold on. Alternate. Is there? Oh, here we go. It's this one. That was hard. Okay, let me show it to you with a different color. Can you see those two parallel lines in green? Can you see that there is a Z shape over here? Give me a thumbs up if you're seeing my green Z. Okay, now what we can say is B2 plus 3 is x. So B2 plus 3, and that's just going to be alternate angles, and then it's going to be BF parallel to CD. So it's because it looks a bit weird, but basically this over here has to be x as well. Yeah, that was quite a mouthful. That was quite a tough question. So if you've never done circle geometry, or if it's not your favorite section, that might have been a bit tough, but it just shows you kind of the process that we had to go through.